Lesson 2, dealing with polynomials. The title of your chart will obviously be just polynomial names. Okay, I want you to know what polynomial actually means. So poly means many. Okay, poly means many. Nomial means terms. So poly, many, nomial, terms. Many terms. Okay? So basically, we're going to be creating this chart of polynomials to demonstrate what each one is. So the first one's going to be a monomial. Mono meaning one, and nomial meaning term. Alright, continuing on our chart, guys. Monomial is the first one. Mono means one. So monomial just means literally one term. So an example of this would be 4y. Okay, so just one term. There's nothing else there. A binomial, bi like bicycle, is 2 because a bicycle has 2 wheels on it. So binomial is 2 terms. Are we talking while I'm talking again? An example of this would be 6x plus 9. 2 terms. Okay? Another example would be anything that is separated by a plus or a minus, right? Next one, moving on up, like a tricycle. This one's trinomial. So a trinomial is really easy. Let's do this. 6x squared minus 9x plus 2. Trinomial, just 3 terms. Okay, and that's typically as far as you'll see it go. There's a 4-term one, but they won't normally ask you to name it. Okay. All right, so there's your chart. Monomial, binomial, and trinomial, and they're all pretty obvious. All right, moving on from there, we need to identify and remember what coefficient is. So let's look at this chart. What is the coefficient here on 4y? Negative. Coefficient is the thing in front of the variable, right? So it's 4. So what is the coefficient in this one? 6. Why is it not 9? Because it doesn't have a variable. What about here on the trinomial? Negative 9 and 6, right? So anything that is in front of the variable, basically, is the coefficient. So if I ask you what is the coefficient of, let's say, 6x squared plus 2xy minus 3y squared, and I gave it to you just like that. I say, what is the coefficient of the first term? 6. What is the coefficient of the third term? 3. Negative 3. Right?
So
what is the coefficient of the second term? What is the coefficient of the second term? 2. Just 2. Okay? This x and y are both variables, so we're looking at whatever's in front of both of the variables. Good? Alright, so moving on. If I'm giving you something, let's just use this one as another example. I'm giving you something like this, and I say, what is the leading coefficient? These have to be in standard form. Standard form is in descending order of magnitude, basically meaning it starts at the highest order of magnitude and moves down. Now, some of you are going, what the heck is order of magnitude? Order of magnitude is just the powers. So if I gave you this, go ahead and write this down. 26x minus 2x squared plus 4x to the 4th minus 3. And I said put this in order of magnitude. I literally mean put the highest power first. So 4, you want it down like this. So I would literally put it in order of magnitude by its power. So 4x to the 4th is the first one that goes. Since it's positive, I just leave it the way it is. Next, I have minus 2x squared, which is the x squared. There was no x to the 3rd. We have to keep that negative with it, okay? So that one's gone now. Next, I have just an x by itself. Since that one's positive, it's 26x. And then minus 3, okay? Your constants, or your just plain numbers, are always going to be at the end. always going to be at the end. Okay?
That's order of magnitude.
Order of magnitude just means put them in order by their powers. This is standard form. Standard form is order of magnitude. Okay? Standard form will always be in order of magnitude. So here we go. From here, I'm going to ask you what the leading coefficient is. If I gave you this problem at the very beginning and said, what is your leading coefficient? You would have to put it in standard form first. But the leading coefficient is literally just asking what is the first coefficient of the first term. What is the coefficient of the first term? What is the coefficient of the first term? 4. So that's all it's asking. Simple? You clear? Just a number. Coefficient is always a constant. It's always a number. You will never have a variable coefficient. Any questions about it? Alright. So, leading term, if I asked what the leading term was, it would be the whole term. So it would have been that 4x to the 4th. Okay, so know the difference between term and leading coefficient. Alright, the degree of the polynomial is, when we're looking at degrees, okay, so we're talking about degree of polynomial here. Degree of the polynomial is, let's write down this example first. Negative 8x to the 5th plus 7x to the 3rd minus 11x squared minus 20. Is that an order of magnitude? Is it in standard form? Yes, right? Because it goes 5, 3, 2, none. Okay, so if I want to know what the degree of this polynomial is, I just look at the leading coefficient. Well, the leading coefficient has a power of 5. So the degree of this polynomial is 5. So you would say it is the 5th degree. It is a 5th degree polynomial. Questions about it? Answer your question? Okay. Alright, so just for clarification purposes, I'm going to give you one more example on this one. So I'm just going to split this box out here. I want to know the degree of this polynomial as well. So if I give you, let's say 20x y squared minus 3x to the 2nd plus 2x squared y squared. First I want to know, is that an order of magnitude? Is it in standard form? You think so? Okay. Now at first glance I would have also said yes. But here's the problem. When you have variables that are bumped up to each other and they're all in the same term, the degree of this term right here is 3. Anybody know why? Because x to the first power, we're actually adding up those exponents. Okay? So if I look at this one, what is the degree of that term right there? Still 2, right? There's nothing extra there. But what is the degree of this term? 4. So an order of magnitude would put this one as the first term, this one as the second term, and this one as the last term. Right? So I would rewrite it like that, just so I can show you. Ooh, that was minus 3x squared plus 20. Oh, I did that wrong. Just don't let me make mistakes. I said that one was second, so we're going to need to write it second. Plus 20xy squared minus 3x squared. Okay, now I got it in the right order here. What is the degree of this polynomial? 4. So it's 4th degree polynomial. And what is the name by number of terms of this polynomial? It is, yeah. I know, we go from complex numbers to this. What is the name of this polynomial by its number of terms? Trinomial. It has 3 terms, right? 1, 2, 3. I even numbered them right here. All right. Any questions about that? All right.
From yesterday's work to this?
I know. Heck of a day. All right. Just to clarify on some definitions here. If I ask for the constant term, I'm asking for the term, the literal term that is just a constant. So I'm going to look up here. The constant term in this, does anybody know? Negative 20. Okay? So the constant term is literally the one without any variables. So a constant term does not have variables. Any questions about that? This is all kind of fast, I guess, but so let me, before I go ahead and write down this definition, I'm just see if y'all guys know what it is. Leading coefficient. What is the leading coefficient of this one? Negative 8. It's the very first coefficient, right? Okay. We're going to create another chart, since y'all guys knew that other word. We don't need the definition for it. We're going to create another chart. We're going to talk about names by degree. So this one's not name by degree. All right. I'll talk about it later. All right, so our name by degree is going to start with degree 1. So let's just put right here degree, and then we'll start this column by listing those degrees. Okay, so if it's a degree of 1, then that name is a linear function or a linear equation. Okay, so its name is linear. If it is of degree 2, then it is a quadratic. If it is of degree 3, it is a cubic. Okay. Any questions about that so far? I'm going to stop my chart there. It continues on, and we'll get into it later, but not right now. Okay? So those are the 3 that you need to know right now. 1 is linear, 2 is quadratic, and 3 is cubic. So let's do an example of each of those. So an example of each of these is really easy to come up with, because all you need to do is look at your degree. If it's of degree 1, then I just make up something that has degree 1. For example, 4x would have a degree of 1. The quadratic would have a degree of 2, so I could say negative 2y squared would have a degree of 2. I could even go further and say, instead of just a one-term thing, I could add another term to it like this, because it's still of degree 2. Okay? And typically you'll see that as another y, but it doesn't matter. The highest order. Okay, cubic, same concept. I could put 3 y cubed minus 2y squared plus 1. Doesn't matter, as long as the highest one is 3. Okay? Any questions so far? Okay, so if they ask you to identify the, let's just go here. Let's identify a linear term. So let's go up to the one where I did the example from standard form. Where is the linear term in this one? 1, 2, 3, 4. Is it the first, second, third, or fourth term? It's the third term because it only has 1 power, right? What about the quadratic term? Say that again.
1.
Quadratic
Or 2.
is the one with the power of 2, right? Since we only have 1 with a power of 2, it has to be the second term because it has a power of 2. Remember, quadratic just means power of 2, degree of 2, okay? Cubic, meaning 3. Is there a cubic? No, there's not one there. Okay, so let's move down.
It has to be exactly 3.
It has to be exactly 3.
Hey, can you go back down to the bottom?
It's exactly 3, not at least 3. It has to be exactly 3. So what about in this one right here? Do we have a cubic term here? Okay, which one is it? First, second, third? Which one? So next to the third, so it's the second term, right? Is there a quadratic? Yes. It's the third one, right? It's this one right here. How about a linear? No, there's not one. Is there a constant term? There's a constant term. It's right there. So if you wanted to add this constant term to your chart, it would have a degree of 0. Of nothing. Degree of 0. All right. That's really all of the definition stuff that I need to go over with you. I'm just going to do a few more examples from the next page. Go to the Connect. I'm going to say A, B, C, and D, and you're going to try to answer me to the best of your ability. Then we'll go over why D is so confusing. Okay, on A. On A. The next page. 2. The literal page number is 15. So A is the square root of 89. We're going to first determine whether each expression is a polynomial. Is it a polynomial? Meaning, does it fall into any of these categories? Monomial, binomial, trinomial. Got Lyle saying it's a monomial. Do we agree or disagree? Okay. It is a monomial. Say that again. You're going to ask. Does not have to have a variable. Because, look back at our examples, this is a 1 and 2 term, right? So this term is just a constant by itself, and it's part of that many term thing. Okay, so it is a monomial.
Can we go back to that? You're running out of
Yeah, you do. Okay. Then we're going to decide if there's a degree to which it falls into. Does it have a degree? How do we know if something has a degree? Well, let's look at our examples here. What is the degree of this one? It's 2, right? We're looking at the exponents on what? On the variables. Are there any variables to add up the exponents on? No. So how many degrees are there on a constant? 0. Okay. And then you would want to explain why. Well, constants don't have a degree. There's your explanation. Okay, so that was A. Let's go to part B. Part B is negative 34 into the negative second. Negative second. Okay, let's see if we can answer this one. First of all, we'd want to probably rewrite this, because it's kind of hard to look at a negative degree. Have we talked about negative degrees at all? Not really, right? We want to rewrite it with a positive degree. So how do I make that a positive 2 instead of a negative 2? I would make it into a fraction. So I'd have negative 34 over what? Into the second. Remember, if I want to move or change it, that was what we went over the first 3 days that we did this. We want to move it, then we have to put it to the other side and make it positive. Or if it's negative, move to the other side and make it, or sorry, if it's positive, move to the other side and make it negative. So, let's talk about it. How many terms are there here? I think it's 2. A term is separated by a plus or a minus. So there's 1 term if it is a polynomial. We need to decide if it's a polynomial. You think this one is? Okay, so this is something we need to add to our definition of polynomial. So maybe go back to your first page or just add it right where you are. Polynomials only have positive exponents. So they only have positive exponents. They only have positive exponents. So, is this a polynomial? No, because why? Anytime, I could repeat, anytime you have a variable in your denominator, it will not be a polynomial, because polynomials will not have negative exponents. Okay? So you say, nope, not a polynomial. So it's not a polynomial because the denominator contains a variable, or you would say it has a negative exponent. Either way, okay? But you need to explain yourself. Okay? Therefore, we can't go to its degree because it wasn't a polynomial. Polynomials have degrees, but since it's not a polynomial, we cannot. Okay? So make that note. It'll make answering one of your problems in your homework really easy. On C, we have 15. S minus 75 s to the third. Is it a polynomial? Yes, it is a binomial, she said. I agree. Is it in standard form? No. What is its degree? 3. It's 3, so it's of degree 3. I agree. So what would that be called if you name it by its degree? A cubic binomial. Cubic binomial. All right, on D. There's a reason that D is so confusing, and I'm going to put a little bit of work on that one before I write it in. So 3x squared plus 7 over x. So I'm going to do this in two different versions. My first version is going to be their original version, and the second version is going to be their original version, but 7 is going to have an x as well. Okay? So, first version. This is technically what in polynomial terms? Because there's a exponent in the denominator, it is what? It is not a polynomial because it has a, guys, this is the part where you talk back. Okay, we need to go back to the first page where I said polynomials only have positive exponents. Polynomials only have positive exponents, meaning they cannot have variables in the denominator. That's the exact same thing, right? Because look, this is a negative exponent. When I move it, it makes a variable in the denominator, right? So they're the exact same thing. So this is not a polynomial. Therefore, it cannot have a degree, or sorry, it does not apply. A polynomial does not have to be a number. This is not a number. That is not a number. S is a variable. Now, the other one I want to show you because this one technically is a polynomial and it has a variable in the denominator. Now, the reason that is confusing is because you can simplify this problem. So you would need to simplify it before you solve it. Now, in order to simplify this, this says divide it by x. So I want to rewrite it so that you can see what it looks like when you divide it by x. It's really 3x squared over x plus 7x over x. Can I simplify 3x over x? And how? I can't have a variable in both the numerator and denominator. I have to move one of them. Which one do I move? The bottom one. Why? Because it's smaller, right? So now this is simplified to 3x. Okay, over here I have an x and an x. Which one do I move? Doesn't matter, right? They're both the same. So that's 1 minus 1, which gives you 0, which is just 1. So plus 7. So this one would simplify to 3x plus 7. So I don't know what you asked there. Add 1 what to where, and then add 1 what to what?
So that is the original problem.
This one right here?
Added an x right here.
This one? I made up this problem here. I made up this problem. This is a completely different problem. I just made it up. This is a completely different example. I'm going to label it E, just so I can add it to your chart. So let's name that by its number of terms. What is it? How many terms are there? 2. So it's a binomial. What is its degree? 1. Just made up this example. That's all I did there. So that you could see that you can simplify it before you try to put it into a specific degree. Alright. What time do we get out of here? 57? Okay. Alright, I just need to show you one more thing then. They're going to ask you to add or subtract polynomials in here. Y'all guys have been doing that since you were a freshman. It's not anything new. Same last name. Add things with same last name. Okay, that's all that is. When it's just different language. But all they're asking you to do is combine like terms. Okay? If it's a minus, go ahead and distribute that negative. Freshman. I know that because I taught it to you guys. Yeah. Alright, now this is one that's just a little bit different because it's not exactly like FOIL, but it is similar to what FOIL is. So write down this example. X plus 3 in parentheses, and then open another set of parentheses, 4x squared minus 6x plus 9. I will know everybody's done writing this down when they put their hand on their desk. As in, drop your pencil. Okay, so everybody should have that written down. Lyle, you good? I can't really see you. Okay. So, to do this, instead of thinking FOIL, remember that every time we FOILed, I just said give this to every piece of the other one. So we would just draw that arrow. So x times x to the second becomes 4x to the third. Okay? I'm just distributing this. Go ahead and write them down as we go. Next one is minus 6x squared. Any questions before I keep going? Okay, multiplying things with like bases, we add their exponents. And then the last one will become 9x. Cool? Alright. Next, I'm going to distribute this 3. So I just go underneath so that all my lines don't get confused. Okay, so since that's positive, it's plus 12x squared. Distribute it to my negative 6. I get negative 18x. Distribute it to my 9, and I get positive 27. Any questions there? Okay, get caught up if you're behind. Now this is the part where I was telling you that they're going to ask you to add polynomials and subtract polynomials. And I say don't get confused because all you're doing is looking up for things that are the same last name. Okay? You're just combining like terms. That's all. Are we good? Alright, so first of all I'm going to look right here, 4x to the third. Is there any more x to the thirds? No. So I'm just going to mark it out and rewrite it below so that I know that I did that piece. Okay? Next, I'm looking at my negative 6x squared. Are there any more x squareds? Yes, there are. So I'm going to go ahead and square those off so I can see them. Okay, I have a negative 6 and a positive 12, which makes a positive 6. X squared. Most common mistake I see here is y'all guys keep trying to multiply on me. It is still the same last name. Okay, don't change the x squared to an x to the fourth. It's still the same last name, x squared. Okay. Next, I'm just going in descending order of magnitude if you didn't figure out why I'm doing it the way I'm doing it. Because I looked at the x to the thirds, now I'm looking at x to the square, or x squared, and then I'm going to look for just regular old x. So here's my 9x. Are there any more x's? Bless you. Are there any more x's? Yes, right here, 18. So I have a 9x and I have a negative 18x. So 9 minus 18 gives me a negative 9x. Right? Keep that last name, bless you. And then I'm looking for things with no exponents, which leaves me just 27. So I'm going to write it down, plus 27. That's it. That's all you got to do. All right, there's nothing else to combine. So here's my question. What is the leading coefficient?
4.
Okay. What is the constant term? 27, right? Everybody understand why constant term is 27? No variables. Good.
You can't add those.
What is the name of this polynomial by its degree? It's a degree 3, yes, but what is its name? Cubic, right? It's a cubic polynomial. Now, it has 4 terms, and we didn't go into how to name something with 4 terms. It's like quintic or something like that. Quartic. It's quartic. Quintic is 5. Anywho, so I think you guys should be good with this. There's a question on here that has to do with area and volume. I want you to do that problem first.